100,000. I want you to just think about that number for a second. That's, on average, how many times your heart beats every single day. It's this incredible engine that just never stops, a pump that's always working. But how in the world does it work so efficiently? Well, the secret is in this brilliant design that sends our blood on a journey not once, but twice.
And that's what we're going to break down today, the heart's incredible double-loop journey. It's this two-part system that's really the key to all of its power and efficiency.
Okay, so let's dive right in. The main idea, the big takeaway here, is that your heart isn't just one pump. No, it's actually two pumps, sort of fused together, working in perfect, beautiful sync. And if you can grasp that, you're going to understand everything that follows. Now, this whole process has a name. It's called double circulation. And it's actually a pretty simple idea when you break it down. For every single trip your blood makes around your body, it has to pass through the heart twice. Think of it like this: once to pick up its fuel, and a second time to go deliver it. A great way to picture it is to think of your heart as this super smart traffic hub. It's managing two different highways at the exact same time. One is a short little loop to the lungs, that's kind of like the gas station to refuel with oxygen. The other one, that's the long-haul trip, delivering that oxygen to the entire country of your body. So let's actually follow the blood on its journey. It all starts with the deoxygenated blood. You know, the stuff that's shown as blue in all the diagrams, even though it's really just a dark red. Its mission is simple. It needs to get a fresh supply of oxygen, and it needs to get it fast. Okay, so the journey kicks off as this used-up, deoxygenated blood gets collected in the right atrium. From there, it just drops down into the right ventricle, which is the pump for this first loop. Then, with a really powerful squeeze, that ventricle launches the blood out through the pulmonary artery, sending it on a short, direct trip straight to the lungs. All right, so the blood has arrived. It's made it to the lungs. Now what happens? Well, this next part is a really simple but incredibly efficient little exchange that gets it all prepped for the main event.
This is basically the transformation scene in our story. This is where our tired blood gets its superpower, a fresh, life-giving supply of oxygen.
You know, it's such a simple but beautiful exchange. The blood gets to drop off its waste product, carbon dioxide, which, you then breathe out, and in that exact same moment, it grabs onto fresh oxygen from the air you just breathed in. And this process instantly transforms it, literally turning it from a darker red to a vibrant, bright red.
And now, our hero returns. It's fully energized, bright red, and ready for its main mission, delivering that precious oxygen to every single cell in your body.
So this brand new, oxygenated blood flows from the lungs right back to the heart's left side, where it enters the left atrium. From there, it drops into the left ventricle. And this is the true powerhouse of the heart, and for good reason. With one massive contraction, it blasts that blood into the aorta, the body's main superhighway, to start its delivery route to every single organ and tissue. And here on this slide, you can see how it all comes together. We have two totally distinct circuits. You've got the pulmonary circulation, that's a low-pressure, short trip just to get oxygen. And then you've got the systemic circulation, a high-pressure, long-distance journey to deliver that oxygen everywhere else. And that's the genius of the whole design. The heart can send blood to the very delicate lungs gently, and then turn around and use its full power to pump that fresh blood to the rest of the body. Two loops, two very different missions, all powered by one incredible heart. So what's really crucial to remember is that this isn't a one-time trip. It never stops. As soon as that red blood delivers its oxygen, it becomes deoxygenated all over again and immediately heads back to the right side of the heart to start the entire cycle over. It's a continuous, never-ending loop that keeps us going every second of every day.
It really is a marvel of continuous circulation. I mean, the system is so efficient and so reliable, it almost defies belief.
So let me leave you with this final thought. Just think about it for a second. There is no engine, no man-made machine that could ever run continuously for 80 or 90 years without any maintenance, without a single break. It just leaves you wondering, what is it about this biological machine that makes it so perfectly and incredibly reliable? Definitely something to think about.